Okay. Okay. Is it the screen is visible to all?
Yes, sir.
Okay. In the previous lecture, we see some examples. Okay. This one. The last one is which one? Reduce the equation n minus 1 bracket square u eta eta minus y raised to 2n into u y y. Okay. u xx, sorry, u xx minus u raised to 2n into u y y is equal to n into y raised to 2n minus 1 into u y. Okay. So there are 5 examples we solve. Now solve these examples in homework. Okay. Sixth one. Sixth one. Homework. Classify the equation. Classify the equation. Okay. Write down these questions. Uxx minus 2 sin x into uxy minus cos square x into uyy is minus, sorry, cos x uy is equal to 0. Okay, reduce this equation. Reduce it to the canonical form. And obtain its general solution. Obtain its general solution. Okay. Write down these questions. Seventh one. Same question here. 4 into uxx minus 4 into uxy plus 5 into 5 into uyy is equal to 0. Okay, classify this equation and reduce it in its canonical form. Eighth one. E raised to 2x into uxx minus 2 into e raised to x plus y into uxy plus e raised to 2y into uyy is equal to 0. Okay, solve these 3 examples to the homework. Now, the next point of our syllabus is solution of one-dimensional wave equation. Okay, we've seen that how the second order partial differential equation generates the one-dimensional wave equation is the origin of second order partial differential equation. Okay, now we have to find the solution of one-dimensional wave equation. Okay, now the first point. The next point is solution of one-dimensional wave equation. Solution of one-dimensional wave equation. Okay. Now, in this one, there are 3 cases are there. Okay, first case. In previous lecture, we seen that what is the first case when the vibration of an infinite string. Okay, both the ends are not fixed. That means both the ends are not fixed means infinite length. Okay, infinite string is there. So in this case one, vibration of a string is infinite. Okay, or infinite string. That is both the ends of that string are not fixed. Both the end of both the end points of string. Both the end points are not fixed. Okay, now look at this solution of this one. So question is there is obtain the D'Alembert solution of one-dimensional wave equation. Obtain the D'Alembert's solution. Okay, D'Alembert solution of the one-dimensional wave wave equation, which describes the vibration of an infinite string. The vibration of an infinite string. Okay, so we have to find the solution of the vibration of a string which is infinite length. That is, both the ends of endpoints are not fixed. Okay, but we know that this differential equation, second order partial differential equation of one dimensional wave equation, that is yxx is equal to 1 upon c square into ytt. Okay, this is the second order partial differential equation of vibration of a string, one dimensional wave equation, vibration of one dimensional wave equation. Okay, so here we have to find the solution of that second order partial differential equation. Okay, so D'Alembert is the scientist which gives the solution of that one dimensional wave equation. Okay, infinite, the vibration of an infinite string. So look at the solution now. Okay, we know that. What we know? We know that the vibration of a string, the vibration of a string, okay, the vibration of a string is described by second order partial differential equation is given by. In the previous lecture, we've seen that. What is the vibration of a string? The second order partial differential equation is given by yxx is equal to 1 upon c square into ytt, in which the two independent variables are there, x and t, and c is constant. When x running from here minus infinity to plus infinity. Why? Because both the ends are not fixed. Okay, so give it as equation number 1. Now, look at it, where y is the function of now what? X and t. इधर तुमचे independent variables कौन है? X and t. So where y of xt, okay, is the solution. Suppose, okay, so y of xt is the deflection. Is the deflection of the string at any time t. Okay, any time is t. Okay, any time t at any point x. Okay, y of xt काय तुमचा हा एक असा फंक्शन आहे जो t या टाइमला x एवढा डिफ्लेक्शन तुमचा असेल at any time t at any point x. x हा पॉइंट असेल तुमचा. Okay, so since the string is infinite, since the string is infinite, okay, infinite, and hence the boundaries of the string are not fixed. Okay, hence the boundaries of the string are not fixed. Okay, so if suppose f of x, if f of x is the function, okay, is the initial initial deflection. Okay, initial deflection म्हणजे टाइम काय असेल तुमचा 0. Okay, so initial deflection of the string and what is g of x? As you know, f of x is the initial deflection of the string and g of x is initial velocity. म्हणजे काय याला काय करायचं डिफरेंशिएट yt of xt, that is nothing but gx is the initial velocity of the string. Velocity of the string. Okay, suppose f of x is the initial deflection of the string and g of x is the initial velocity of the string. Okay, then the function y of xt, okay, is required. म्हणजे हा काय पाहिजे तुमचा y of xt काय करायला पाहिजे, हा इनिशियल आणि डिफ्लेक्शन आणि इनिशियल वेलोसिटीची कंडिशन काय करायला पाहिजे, सॅटिस्फाय करायला पाहिजे. सो द फंक्शन y of xt is required. So हा तुमचा सोल्युशन असेल डिफरन्शियल इक्वेशनचा. ओके, सो इज रिक्वायर्ड to satisfy the initial condition. Okay, initial condition, that is y of x. Initial time किती असेल तुमचा 0. ओके, म्हणजे काय इनिशियल हा काय डिफ्लेक्शन झाला ऍट टाइम 0, that is nothing but f of x. Okay, give it as equation number 2. So this is the initial deflection at time. Initial deflection म्हणजे काय ना, हा टाइम t is equal to 0. Okay, in the bracket right now, this gives the initial deflection of this string. This gives initial deflection of this string. Okay, and if y of x is the deflection at point x at any time t, then yt of x0, okay, is nothing but what? Velocity. Differentiate with respect to time and the time available velocity. So yt of x, okay, at time 0 is equal to what? G of x. We assume that this is the initial velocity. Okay, so yt of x0 is the g of x. Give it as an equation number 3rd. So write down in the bracket, this gives the initial velocity of that string. This gives initial velocity of the string. Okay, up to here any doubt? काही डाऊट असेल तर विचारू शकतो. हॅलो, आवाज ऐकू येते माझा?
येस सर.
ओके, काही डाऊट आहेत का इथपर्यंत?
नो सर.
Okay, so our aim is to find the solution of the second order partial differential equation which satisfies both these conditions, like equation number 2 and equation number 3. Okay, so thus our problem is to find the solution of the one-dimensional wave equation 1. Okay, equation 1 आपल्याला काय करायचं, सोल्युशन फाइंड आउट करायचं, satisfying initial condition, that is equation number 2 and 3rd. Satisfying initial condition. Okay, so what is the equation number 1? Equation number 1 is nothing but ytt is equal to yxx. Yxx is equal to 1 upon c square into y dt. Okay, this implies yxx minus 1 upon c square into ytt is equal to 0. Okay, on comparing equation, this equation, okay, that is equation number 1 with the standard form. What is the value of r, s and t? So look at it. On comparing above equation with standard form, standard form, what is the value of r? That is the coefficient of uxx. Here y is the dependent and x and t are independent. Okay, so what is the value of what is the coefficient of yxx is 1. Okay, s is equal to 0. Coefficient of yxt 0. Okay, and what is the value of t? Minus 1 upon c square. Okay, now consider the discriminant. Consider discriminant s square minus 4rt. Okay, tell me what is the value of this one. S square is 0. Okay, minus 4 into 1 into 1 upon c square minus. Okay, so this gives 4 upon c square, which is greater than 0. Okay, as as s square minus 4rt is greater. Okay, 4rt is greater than 0. Equation 1 has which form? Hyperbolic form, greater than 0 symbol. Hyperbolic canonical form. Okay, any doubt up to here? Okay, now we have to find the root of the quadratic equation r lambda square plus s lambda plus t is equal to 0. Okay, now the roots of the roots of the quadratic equation. Quadratic equation r lambda square plus s into lambda plus t is equal to 0. Okay, what is the value of r? Is 1. Lambda square plus 0 minus 1 by c square into 1. Okay, this is equal to 0. So we get lambda square minus 1 upon c square is equal to 0. Okay, so this implies lambda is equal to plus or minus 1 upon c. Okay, any doubt? Now take,
No, sir.
let alpha 1 is equal to 1 upon c. Okay, and lambda 2 is equal to minus 1 upon c. ओके, सेम प्रोसिजर करायचं आपल्याला. सोल्युशन कसं काढतो तसं कॅनॉनिकल फॉर्म मध्ये करताना तसंच करायचं आहे. ओके, फक्त इथे काय करायचं आहे, जो काही शेवटी कॉन्स्टंट आहे तो इनिशियल कंडिशन यूज करून आपल्याला काय करायचे, इनिशियल डिफ्लेक्शन आणि काय ते इनिशियल वेलोसिटी आणि इनिशियल डिफ्लेक्शनचा यूज करून आपल्याला दोन फंक्शन फाइंड आउट करायचे, जो काय फंक्शन कॉन्स्टंट आहे. Okay, so lambda 1 is equal to 1 upon c and lambda 2 is equal to minus 1 upon c. Hence, the ordinary differential equation is the ordinary differential equation. Which one? dt by which one? dt by dx. Okay, plus lambda 1 is the function of xt. Okay, is equal to 0 and dt by dx is equal to plus lambda 2 of xt is equal to 0. Okay, so this implies minus is plus, sorry, plus is plus. Okay, that is dt by dx plus 1 upon c is equal to 0 and dt by dx minus 1 upon c is equal to 0. Okay, so this implies dx plus c into dt is equal to 0. Okay, and dx minus c into dt is equal to 0. So on integrating we get what we get x plus ct is equal to c1 and x minus ct is equal to c2. Okay, now again we have to change the independent variable x and t to psi and eta. Okay, now we change the independent variable x and t. Okay, x and t to the new independent variable. Independent variable, which is psi and eta. Okay, by using transformation equation, using the transformation equations. Okay, so let psi is equal to c1, that is x plus ct. Okay, give it as an equation number 4, and eta is equal to x minus ct. Give it as an equation number 5. Okay, तुमच्या इथे काय y independent variable. Okay, now zeta and eta are the independent on independent variable. हा y तुमचा dependent झाला. Now psi and eta is the function of x and t. Okay, not x and y. And eta is the function of x and t. Okay, so this is equation number 4 and 5. Now find out the value of chi in psi x. Now what is psi x is equal to 1. Psi double x is equal to 0. Okay, psi t is equal to c. Okay, psi double t is equal to 0. Okay, the t का घेतलं बघा independent variable पण आहे तो, not y, t आहे. Okay, similarly eta x is equal to 1, eta double x is equal to 0, eta t is equal to minus c, and eta double t is equal to 0. Okay, so we know that what is y-axis. Now by using the, the chain rule of the partial differential equation. The chain rule of partial differential equation. The value of y-xx. Find out the next. So y xi into xi x square plus 2 into y xi eta into psi x eta x. Okay, plus y eta eta into eta x square plus y xi into xi xx plus y eta into eta xx. Okay, so this is the value of y double x. Okay, we've seen in the previous lecture the value of y-xx. Now putting the value of xi x, eta x, okay, and psi double x and eta double x, what we get? So this is value of xi x is 1. Okay, so this is y double xi plus 2 into y xi eta. The value of this is 1, 1, half 1 egg, half 1 egg. Okay, half it 0, 0. So plus y eta eta. Okay, and value of ytt now. Ytt is equal to y psi xi into xi is the function of t na, psi t square. Y xi eta into psi t into eta t plus y eta eta into eta t square. plus y xi into xi tt. Okay, instead of x, replace the t. Okay, so this is y eta into eta is the function of pt. Okay, now putting the value of xi t, eta t, and xi double t and eta double t. So we will get c square. Okay, xi t is nothing but c. Okay, c square into y double xi plus 2y xi eta into minus c square. C into minus c, that is minus c square. Xi t eta is okay, this is minus c square. Okay, हा ब्रॅकेट मध्ये नाही आहे, मायनस घेऊया, minus this is c square. Okay, plus y eta eta, and this is minus c square is nothing but c square. The value of this one is 0 and 0. So this is equal to c square into y double xi minus 2y xi eta plus y double eta. Okay, so this is the value of y double t. Now the putting the value of yxx and ytt in the equation number 1. So what we get? Putting the value of yxx and ytt in equation 1, we get what is equation number 1? Y double x is equal to 1 upon c square into y double t. Yes. Now, after putting, we get y axis is nothing but y double xi into plus 2 into y xi eta plus y double eta is equal to 1 upon c square into this one is c square into bracket y double xi minus 2y xi eta plus y double eta. Okay, now this c square will cancel. Okay, after simplification, काय cancel होईल? हाही cancel होईल तुमचा. ओके, अजून काय cancel होईल? हा पण cancel होईल. प्लस प्लस आणि हा काय होईल? प्लस 2y xi eta and this is हा इकडे आली प्लस, so that implies 4y xi eta is equal to 0. That is implies y xi eta is equal to 0. Okay, now integrating we get. So now this is the canonical form. हा तुमचा काय आला? Canonical form. Okay, याला integrating with respect to eta and xi केला जाईल solution. Form. Okay, now integrating we get first time integrating केल्यानंतर काय येईल? y xi with respect to eta केल्यानंतर काय येईल? A function of xi. Okay, function of xi. Okay, काही येऊ शकेल, हा 0 येईल, कॉन्स्टंट येईल, काही येईल, पण फंक्शन ऑफ xi येईल. कसा येईल पहा. Again on integrating with respect to now xi. So here we have y is the function of xt with the function of xi plus function of eta. ओके, कळते कसं आलं? हा या इक्वेशनला डिफरन्शिएट विथ, हा या इक्वेशनला डिफरन्शिएट विथ रिस्पेक्ट टू eta करा, काय येईल? हा येईल मग. ओके, कळते का? तर कॉन्स्टंट येईल असं, याचा अर्थ कॉन्स्टंट येईल असाही नाही, तो फंक्शन ऑफ xi पण असू शकतो इथे. ओके, now using the first initial condition, okay, equation 2 and 3 we have to find the value of f of xi and g of eta. हे दोन फंक्शन आपल्याला फाइंड आउट करायचे. Okay, what is the function value of xi and eta? Now putting the value of xi and eta we get y or is the function of xt is equal to f of capital F of, okay, that is nothing but x plus c, okay, plus g is the function of eta, that means x minus c. Okay, give it as an equation number 6. Okay, where f and g, with f and capital G are arbitrary functions. Okay, so this is the general solution of equation 1. So this is the general solution of equation 1. Okay, now using initial condition, we have to find this arbitrary function, value of this arbitrary function. Okay, now if this is the solution of that differential equation, second order differential equation, हा जर solution असेल म्हणजे हा initial condition ही satisfy करायला पाहिजे. कोणकोणते initial conditions आहेत? What are the initial conditions? Look at this one. Equation 2 and equation 3rd. Okay, ह्या equation ते satisfy करायला पाहिजे. Okay, now look at here. This is the general solution of equation 1. The solution 6. Okay, the above equation, that is solution 6 is required to satisfy the initial condition. To satisfy the initial condition. Okay, initial condition 2 and 3. Okay, that is equation 2 काय तुमचा y of x0 is equal to f of x. Okay, now put t is equal to 0 in equation number 6. त्याच्यामध्ये जर t 0 ठेवला तर काय येईल? हा तुमचा इक्वेशन 2 आहे. ओके, हा इक्वेशन 2 आहे आणि याच्यात जर मी 0 ठेवला तर काय येईल? हा y is equal to x0 is equal to capital F is the function of x. Okay, t हा 0 झाला plus capital G is the function of x. Okay, after putting the value of t is equal to 0. Okay, now comparing these two equations, we get small f of x, that is the initial deflection, is equal to capital F of x, which is arbitrary function, and capital G of x. Okay, so give it the equation number 7. Okay, now we have to satisfy the equation also third one. What is the equation third? Yt of x0, initial velocity of that solution. Okay, initial velocity of that string, sorry. Okay, what is the equation third right here? काही कंडिशन तुमचा satisfy करायला पाहिजे. कोणता? Yt of x0 is equal to small g of x. Okay, that is this gives the initial velocity. ह्याला डिफरेंशिएट आधी t ने डिफरेंशिएट करावं लागेल, मग put t is equal to 0. Okay, so differentiate equation number 6 with respect to partially with respect to 6. Okay, this equation. Okay, after differentiating we get differentiate first one. Differentiate equation 6 partially with respect to t. We get the velocity. Okay, so yt is the function of xt is equal to काय differentiate केल्यानंतर c into f dash of x plus ct plus minus c into g dash of x minus ct. Okay, so this gives c into capital F dash of x plus ct minus, to the minus है ना, g dash into, g dash is the function of x minus ct minus c. Okay, which is nothing but initial now. Now put t is equal to 0. What we get? Yt of x0 is equal to c into capital F dash of x minus c into capital G dash of x. Okay, but yt of x 0 is nothing but what? Small g of x. So this implies small g of x is equal to c into capital F dash of x minus c into capital G dash of x. Okay, so this is our initial velocity. Give it an equation number 8 there. Okay, and this is equation number 9. आता या दोन्ही इनिशियल कंडिशनचा वापर करून आपल्याला काय करायचं? फंक्शन ऑफ एफ अँड जी हा आर्बिट्ररी फंक्शन आहे ते फाइंड आउट करायचे. जिथे आपण इनिशियल कंडिशन वापरून C1 C2 फाइंड आउट करतो, इथे आपल्याला काय करायचे? इनिशियल कंडिशनचा यूज करून आर्बिट्ररी फंक्शन्स फाइंड आउट करायचे. Okay, so g of x is equal to c into f dash of x minus c into g dash of x. So this is equation number 9. Okay, so integrating equation 9 from x naught to x. Integrate this equation. Okay, you have to find the value of f and c. G ना आपल्याला f आणि g ची व्हॅल्यू करायची. मग इथे f आणि g, इथे f आणि g आहे कुठे? या इक्वेशन मध्ये. ओके, इंटिग्रेटिंग केल्यानंतर काय येईल? मग हा f आणि g मध्ये येईल. मग तुमच्याकडे दोन आर्बिट्ररी फंक्शन्स, दोन इक्वेशन्स आहेत, आर्बिट्ररी इक्वेशन. ओके, त्या दोन्हीचा वापर करून काय करायचं आपल्याला? कॅपिटल एफ अँड स्मॉल जी व्हॅल्यू, कॅपिटल जी ची व्हॅल्यू फाइंड आउट करायची. ओके, सो इंटिग्रेटिंग इक्वेशन 9 फ्रॉम x naught to x. Integrate equation 9 from x naught to x. Okay, we get. Okay, हा तुमचा x naught काय इनिशियल पॉइंट आणि हा आर्बिट्ररी पॉइंट. So we get integrating x naught to x g of s, okay, into ds. Change the variable x to s is equal to c into, already integration केलं काय येईल? f of x minus, okay, c into capital F of x naught minus c into, याला डिफरेंशिएट केल्यानंतर काय येईल? g of x minus minus आहे प्लस होईल. ओके, c into g of x naught. Okay, that is equal to now taking c common, that is after simplification we get 1 upon c into x naught to x into g of s ds is equal to f of x minus g of x minus capital F of x naught plus capital G of x naught. Okay, any doubt up to here? Give it an equation number 10. काही डाउट आहेत का? कोणती स्टेप समजत नाहीये? ओके, तुमचा एफ ऑफ एक्स नॉट आणि हा वाय नॉट एक्स नॉट काय तुमचा इनिशियल पॉइंट आहे, म्हणजे हे तुमचे काय असणार? कॉन्स्टंट असणार बरं का. पर्टिक्युलर पॉइंटला तुमची फंक्शन व्हॅल्यू देते, म्हणजे हा काय कॉन्स्टंट आहे तुमचे, के कुठले तरी कॉन्स्टंट आहेत, के आणि के डॅश. ओके, नाव लुक एट हियर. इक्वेशन 6 पहा, इक्वेशन 7 पहा. हा एक तुमच्याकडे इक्वेशन आहे एफ आणि जी मध्ये. ओके, नाव इक्वेशन 10 is in f and g. So using equation 7 and 10, find the value of f of x and g of x. Okay, so we have adding and subtracting equation 7 and 10. तुमच्याकडे दोन इक्वेशन्स आहेत आणि दोन अननोन्स आहेत, f and g. ओके, त्याची व्हॅल्यू तुम्हाला फाइंड आउट करायची. ऐकू येतोय ना माझा आवाज?
Yes, sir.
Okay, so we get after adding and subtracting, first we get after adding capital F of x is equal to, डायरेक्ट घेतोय मी स्टेप. ऍडिंग केल्यानंतर काय येईल मला? f of x. हा काय होईल? ऍडिंग केल्यानंतर हा 2 टाइम्स येईल, 2f of x, आणि हा इक्वेशन मध्ये 10 मध्ये एक f of x, म्हणून हा 2f of x होईल, आणि तिकडचा प्लस g of x मायनस g of x कॅन्सल होईल. ओके, कॅल्क्युलेशन करून पहा. 1/2 हा इकडे केल्याने 1/2 येईल into bracket f of x, okay, small f of x आहे, plus 1/c into integration x naught to x g of s into ds. okay, हा एक bracket येईल plus 1/2 into capital F of x naught minus capital F of हा तुमची कॉन्स्टंट. ओके, जो इक्वेशन 10 मध्ये आहे तो असा आहे तसा येईल इकडे. फक्त इकडे 1 जो 2 f of x येईल तो इकडे काय होईल, डिवाइड होईल. Okay, so this is the value of f of x after adding, and after subtracting we get the value of g of x is equal to 1/2 into small f of x minus 1/c into integration x naught to x g of s ds plus 1/2, sorry the minus a, this is sorry minus 1/2 into capital F of x naught minus capital G of x naught. Okay, so these are the values of f and capital F and capital G. Now putting the values of capital F and capital G in our solution. What is the solution? Equation number 6. हा तुमचा सोल्युशन इथे पुट करा. ओके, जर f हा तुमचा f of x जर असा असेल तर f of x minus ct काय येईल? ओके, रिप्लेस x by x minus ct. प्रत्येकाकडे काय येईल तुमचा x minus ct येईल. ओके, इथे पण x minus ct. ओके, g of x minus ct काय येईल? इथे x minus ct, इथे x minus ct. Okay, so putting the values of f of g and g, f of x and g of x in equation number 6. So using capital F of x and capital G of x in equation number 6, we get now look at here, y of xt. Okay, what is y of xt? काय होतं तुमचा? Capital F of x minus ct plus capital G of x minus ct. Okay, f of x हा आलाय म्हणजे g of x काय येईल तुमचा? f of x हा आलाय तुमचा, मग g of f of x x minus काय येईल? x minus ct काय येईल? जिथे जिथे x आहे तिकडे x minus ct येईल. Okay, so y of x minus ct is equal to 1/2 into bracket small f of x minus ct. Okay, plus 1/c into x naught to x x minus ct, sorry, x minus ct, sorry, f of x plus ct ना, आपल्याला f of
Yes, sir.
x minus ct काढायचं. इक्वेशन 6 मध्ये f of x minus ct काढायचं. ओके, this is g of x naught to x minus x plus ct into g of s, g of s into ds. Okay, plus 1/2 into height is f of x naught minus capital G of x naught. Okay, minus plus value of capital G of x 1/2. Okay, into f of x minus ct now. Okay, g of x म्हणजे काय हा असेल तर g of x minus ct काय येईल? जिथे जिथे x आहे तिथे replace x by x minus ct. Okay, x minus ct minus 1/c into integration x naught to x minus ct g of s into ds. Okay, minus 1/2. ओके, इथे प्लस आहे बरं का, आणि इथे मायनस into bracket capital F of x naught minus capital G of x naught. Okay, so this is our solution which satisfies the also initial condition. Okay, after simplification काय होईल? सिम्प्लिफाय केल्यानंतर कॅन्सल होईल, प्लस मायनस. ओके, हा प्लस हा प्लस मायनस मायनस हा पण काय होईल? कॅन्सल होईल. ओके, अजून काय कॅन्सल होईल? हा नाही कॅन्सल होणार बरं का, ते एक्स प्लस सी टी इकडे एक्स मायनस सी टी. Okay, so y is the function of x and t, that is solution of the given partial differential equation. Okay, is equal to, taking 1/2 common from this one, f of x plus ct plus f of x minus ct. Okay, into bracket. पुढे काय येईल? हा एक्स नॉट टू एक्स प्लस सिटी, हा एक्स नॉट टू एक्स मायनस सिटी. ह्याला मी तर प्लस केला आणि हा वर हा खाली घेतला तर काय होईल, एक्स नॉट टू एक्स प्लस सिटी. ह्याला काय करावं लागेल, चेंज करावं लागेल, इंटिग्रेशन चेंज होते, थांबा कसं होईल सांगतोय. अपॉन 1/2c इंटू इंटिग्रेशन फ्रॉम एक्स सिटी मायनस 1/2c इंटू एक्स मायनस ct टू एक्स प्लस ct. ओके, ह्याला सिम्प्लिफाय करायचं, g ऑफ s इंटू ds. सो दिस इज द रिक्वायर्ड सोल्युशन. कसा आला पहा, हा काय केलाय, एक्स नॉट टू एक्स प्लस ct. ओके, इथे काय तुमचा काय येईल, हा प्लस मायनस 1/c, तर मायनस आहे, सॉरी ते मायनस आहे, ते मायनस आहे. ओके, हा वर घेतला आणि हा खाली घेतल्यानंतर काय येईल, हा इथे प्लस येईल. ओके, मग काय येईल, एक्स मायनस सी टी टू एक्स नॉट अँड एक्स नॉट टू एक्स प्लस सी टी, म्हणजे काय येईल, हा एक्स मायनस सी नॉट टू एक्स प्लस सी टी. ओके, आणि हा
Yes, sir.
1/2c आहे तसं. कळालं का कसं ऍडजस्ट केलंय टर्म.
Yes, sir.
ओके, पहा नीट, हा इथे मायनस होता, त्याला मी प्लस केला आणि हा लिमिट वर घेतला आणि हा लिमिट काय केलंय, खाली घेतलंय. मग काय येईल तुमच्या इथे लिमिट, एक्स मायनस सी टी टू एक्स नॉट, नवीन आलेलं लिमिट, आणि हा काय एक्स नॉट टू एक्स प्लस सी टी, म्हणजे टोटल लिमिट काय झाला माझा, एक्स मायनस सी टी टू एक्स प्लस सी टी. ओके, आणि हा 1/2c कॉमन and g of s ds. Okay, so this is our solution of this one-dimensional wave equation which satisfies the initial condition also. Okay, where f belongs to, okay, small f, this one, small f is belongs to C2, that is the set of all continuous functions with two time differentiable, and G is the belongs to C1, set of all continuous function which is differentiable, one time differentiable. Okay, so this is called the D'Alembert's solution, which describes the vibration of an infinite string at any point x and at any time t. Okay, any doubt? So this is the solution of the one-dimensional equation wave. Okay, मागच्या लेक्चरला काय पाहिलं होतं आपण, दोन लेक्चर आधी, origin of one-dimensional wave equation. Sorry, the origin of second-order partial differential equation is one-dimensional wave equation. ओके, त्या डिफरन्शियल इक्वेशनचा आपण काय काढलं, सोल्युशन काढलं. ओके, जर याला इनिशियल हा आलेला आन्सर चेक आहे का नाही, करेक्ट आहे का नाही, काय करणार मग ह्याला, y ऑफ x 0 ठेवा, काय तो पहा, y ऑफ x 0 आल्यानंतर तुमचा काय यायला पाहिजे, स्मॉल f ऑफ x येतो का, पहा स्मॉल f ऑफ x येतो. ओके, पुट t इज इक्वल टू 0, t इज इक्वल टू 0 ठेवल्यानंतर काय येईल, हा इथे 0, इथे x येईल, इथे पण x येईल, x टू x काय असतो तुमचा इंटिग्रेशन 0, म्हणजे ही टर्म काय झाली तुमची पूर्ण 0. ओके, इथे काय येईल, f ऑफ x प्लस f ऑफ x. Okay, that is 2f of x. The 2 and this 2 get cancelled. So here y of x0 is nothing but small f of x. That is equation number 2. Okay, त्याचप्रमाणे काय करायचं, याला डिफरन्शिएट करा. डिफरन्शिएट केल्यानंतर इथे डू बाय डोटी आणा. ओके, याचा रूल आहे पुन्हा वेगळाची. आज गेल्यानंतर काय येईल, तो रूल आहे, तो रूल आपण पुढच्या ह्याला बघूया. ओके, so this is the solution of one-dimensional wave equation which satisfies the initial condition. Okay. So in the next lecture, we have to see that the vibration of semi-infinite string. That is, one end is fixed and another is not fixed. Okay. Wait a minute. Any doubt up to here? काही doubt असेल तर विचारू शकता.